In this video, we're going to be looking at some specific example problems that allow us to use the law of sines. Now, we have learned the law of sines is used to find missing sides or angles of triangles that are oblique or non-right triangles. And we have seen the formula as highlighted in yellow and it's boxed here. We've seen this formula. Now, sometimes we can use this formula as its reciprocal, which is here boxed in blue. I use the one on the left-hand side when I'm solving for the missing angles in a triangle. And when I'm solving for missing sides, I use the right-hand side with the lowercase ABC in the numerator. And the reason is that this is just for your convenience. It just makes, it reduces the amount of steps you have in using the formula. So that's something that will be useful to know. Now what we need to talk about is when are the cases that we are allowed to use law of sines? When do we use it? And there are generally three typical cases. One, we're only going to be looking at two. So the first one we're going to be looking at is angle side. That's when you're given two angles and one non-included side. An example of that is here, I'm going to draw it. You're given a non-right triangles. This, let's say it's 45 degrees and this is 67 degrees. You have two angles and I'm going to give you a non-included side, so maybe here. And this is an example of angle side. If I were solving for the missing side x, I'll be using the law of sine. The next one is angle side angle. Angle side angle, again, you are given non-right triangle. You can be given two angles. And you have to have one included side. So this part where it's between the two given angles. That's an example of angle side angle. And if I were solving for another missing side, again, I'll be using the law of sine. Now the third one, which is side angle. This is a special one, okay? When we are dealing with side angle case, we have to be careful and we have to pay attention to this type of triangle. In math, we call this type of situation the ambiguous case. But in this lesson, we will not be talking about the ambiguous case or the side angle triangle. So please do not worry about them. So let's look at the first example. In the example, you are given two angles and a side. So first is I'm going to draw the diagram, labeling the angles in capital letter A, B, C. It doesn't matter how you label them, but this is what I'm going to do. Angle A is 28 degrees. Angle C is 102 degrees, and the side that's opposite to capital A will be the lowercase a, which is 27 centimeters. Now, this looks like angle side case. Okay, so we're going to start with an example of angle side, and now I'm allowed to use the law of sine to solve for the missing side C. So how do we apply the law of sines? Well, the law of sine is a relationship between the sine of opposite angle and the side. So I can be using, I'm solving for side C, and it's opposite to the sine of angle C, which is 102 degrees. And by the rule of law of sine, this should be equal to the relationship between side A, which is 27 centimeters, and the sine of angle A, which is 28 degrees. And we can solve this by cross multiplying. So I have C times sine of 28 degrees equal to 27 times sine of 102 degrees. And I'm going to divide both sides by sine of 28 degrees to solve for C. If you put this in your calculator, you will have approximately 50 6.3 centimeters. We're going to round it to 10th place. And here is my answer for side C. Let's look at the next example. In the next example, we're also given two angles and a side, and we're looking for side A. So again, start by drawing the diagram. I'm going to call each angle capital ABC, 66 degrees here, 34 degrees. And I'm looking at side C, and I'm giving that this is 12 centimeters. With all this in place, I'm giving two angles and an included side. So this is a case of angle, side, angle, which is our second case here. To apply this sine law, or the sine rule, I need to have a relationship between an opposite angle and its side. So since I have side C, I should be using angle C, which is unknown at the moment. And I need another relationship, either angle side and side A, angle 34 degrees, which is angle B and side B, but I don't have any of those information. Well, one angle that I can actually find is the measure of angle C. Because if I know two angles in a triangle, I can actually find the third side by triangle angle sum theorem, because all angles add to 180 degrees. So I can do 180 degrees minus 66, the angle A, minus 34. And this gives me the measure of angle C, which is 80 degrees. So I have found that this is 80 degrees. And since I'm finding the side A, now I can use the sine rule using the relationship between the angle C and the side C that is given. So I'm going to put A over sine of angle A, which is 66. Again, I'm starting with my variable because that's what I'm solving for. And that should equal to side C, which is 12 centimeters over the sine of angle 80 degrees, the angle C. And same thing, I'm going to use the cross multiplication, which is A times sine of 80 degrees equals 12 times sine of 66 degrees. Divide both sides by sine of 80 because we're solving for A. And A is equal to 12 times sine of 66 degrees all over sine of 80 degrees. That will be a non-calculator answer, but if you put it in the calculator, this will approximately be 11.1 centimeters. And that's the measure of the missing side C. So now we've looked at two cases when we can apply the law of sine. First one is the angle side, and the second one is angle side angle. And again, the third one we will not be covering in this lesson.